So there we go. I believe you can see it now. The title of my talk is The Quantum Ecosystem Needs You. And we heard some great presentations yesterday. Those are sort of what I think of as the, in some sense, what is quantum and why are we excited about it? I'm going to talk a little bit more about, I guess what you might say is the how. How is quantum advancing? Who are the players that need to be involved? And what can you perhaps do to be part of this ecosystem? So what is the quantum ecosystem? I sort of put together a graphic that just illustrates all the different parts of what I think of as the quantum ecosystem. And I do focus here initially on the science and engineering and technology pieces. But as this slide shows, there are researchers, there are people who are educating the scientists and engineers and funding agencies, but there are many more parts of the ecosystem. There are people who are in these national labs around the world. There are developers, so we've got researchers, but also developers who are taking the results of research and making them into practical things. There are the investors, as well as funding agencies, private investors who are investing in startups and incubators and helping to get things out of the lab and into practical applications. There are the folks who are making things, and then there are the end users. Ultimately, quantum applications need to do something useful, and engaging the end users in the ecosystem early is important because they're going to pull the technology toward useful purposes. So we've got this big ecosystem, lots of different players that are in it. And another way of thinking about the ecosystem is in terms of the innovation process. So this rather busy chart shows the process in terms of moving from really basic research, shown up here on the top left, according to sort of a description, basic research, and also what we think of as the technology readiness level. So technology readiness level scale goes from 1 to 9, and so it starts at the lowest levels with very basic research, then applied research and prototyping and so on. And so there's the sort of linear process that's often described, but of course, it's messier than that. There are people who are doing more applied work and development work who realize I need some basic science here to be done. And so it's a very sort of convoluted loop of activities going on from the basic research through the development process. Ultimately, things get handed off, and that's where industry really picks up and starts to scale things up and worry about manufacture and ultimately maintenance and operation issues even. So the investment by the government investors tends to be at the early stages. And so what I have listed here as federally funded research lies on the left-hand side. At some point, that work needs to transition to more applied R&D and development activities. And that's often described as the valley of death, where it's hard for things to move past the research stage into applications. And that's an area that is important to focus on and make sure things don't sort of die because of lack of investment at that stage. At the bottom, I just want to draw your attention to the different fields and expertises that are needed as part of this whole process. And there are disciplines like science and computer science and so on, or physics, materials, engineering research. Then as you get into the more applied work, there are activities like testing and evaluation and validation, verification of making sure that processes work and that things behave and perform properly, and ultimately, of course, manufacturing. And so there's, just like the previous slide that showed the innovation ecosystem, there are a lot of different expertise and capabilities that are going to be necessary for something to move from the basic research stage through to application and manufacture and commercialization. So this sort of big ecosystem needs to come together to be efficient. And I'll talk a little bit now about the organization that I'm part of, which has the purpose to help do that. It's called the Quantum Economic Development Consortium, and it was actually called for in the legislation that was passed at the end of 2018 in the US, which is called the National Quantum Initiative Act. And it has a section in it that calls for NIST, the National Institute for Standards and Technology, which is in the Department of Commerce in the US. NIST is to create a consortium of stakeholders to identify needs to support development of a robust QIST industry in the United States, quantum information science and technology industry. And if you read this piece of legislation, it's easy to find. You can see what this consortium is supposed to do. So it's to assess what the current research needs, research is addressing these needs. So identify the needs. What research is going on now to address the needs? What are the gaps in research that's needed to address the needs? And then recommend how this initiative can address the gaps. So very sort of basic gap analysis and making recommendations on how to bridge the gap, fill the gaps. NIST selected SRI International, my employer, to manage this Quantum Economic Development Consortium, the QED-C, and that was in 2018. So we've been going for almost 2 years now. And it feels a little bit like a startup. We're creating something new. It's very exciting. So the Quantum Economic Development Consortium today comprises 180 organizations, mostly over 130 are corporations and U.S. corporations. So right now we're working within the U.S., but during 2020, we expect to open it up to beyond just U.S. organizations. So we've got companies, we've got about 36 now, or over 30 universities that are participating. We have some of the U.S. national laboratories involved, and also other organizations, professional societies, and so on that are part of that ecosystem that I showed at the beginning. And I just sort of indicate here that these companies and universities, but especially the companies, do cover the whole sort of supply chain and involve hardware and software, suppliers of components, many of which are not quantum. So we need lasers, we need cryogenic systems, we need vacuum systems and photonics. All of these are technologies that are going to have to be advanced specifically to enable quantum applications. And we have others like law firms that are interested in quantum patents, investors, professional societies, and so on. And also the other sort of dimension that we cover is the many applications of quantum. So we have companies that are interested in quantum computing, but also those that are interested in other applications in sensing, metrology, cybersecurity, communications, and so on. So the mission of the QED-C is very simple, is to enable and grow a robust quantum industry. So in order to achieve this goal, we have a number of purposes or goals inside that. The mission is going to be reached by these goals, achieving these goals. First of all, as the legislation creating the consortium indicated, we are to identify the gaps, the needs and the gaps. And those are in technology areas and especially enabling technologies. So we sometimes say that QED-C is not about the qubits, it's about all the technologies around the qubit. And so we're hosting workshops and we're doing deep dives and developing roadmaps in various enabling technology areas. We also recognize that in order for anything to become commercial, it's often important to develop standards. And so we have a committee that's working on understanding the standards landscape, what's going on, what standards are being developed, what standards might be needed in the future. And not just technical standards, which often are needed when something is fairly mature and ready to be interoperable. We're pretty early in quantum, and so we're really more at the stage of needing to measure progress, coming up with metrics and benchmarks. And then there's a sort of cross-cutting need for workforce, and I'll focus a little bit on that today. In fact, one of our goals or purposes is to interact with the government, which has a strong interest in developing a good workforce pipeline. And so our group, which has strong representation from industry, can collectively identify what workforce needs they have and communicate that back to the educators and to the government that's funding education programs. So I'd like to just present a little bit of information that we collected doing a survey last year from our member companies. At the time, we did not have 180 members. We had about 45, I think, and 22 of them responded to the survey. So these data are based on a small sampling, in a way, of the industry, but it's a fairly diverse group, and this chart just indicates that we had companies that were large, more than 600 employees, down to very small ones that had less than 30 employees. So it's a good cross-section in terms of the types of companies, the size of companies, also the nature of their business was quite diverse. Now, a big company that has 600 or more employees, you can think of what they might be. We heard from some of them yesterday, Honeywell, for instance, IBM, others. Inside of them, they sort of have a quantum startup, right? Because they don't have everybody at the company working in quantum. Some small companies like IonQ or Rigetti or D-Wave are pure play quantum companies, and all of the employees who are technical are quantum workers. So again, there's a rather diverse mix of respondents. And when we ask them how many of your employees are quantum workers, it was a much smaller number than the total number of employees in general. So here, a large quantum workforce might be over 40 people working in quantum. And small, we called 1 to 10. These are somewhat arbitrary, but we asked them, how many of your employees are quantum workers today, and how many do you think will be in 3 years? And the number that said that they were large, medium, or small went from what you see on the left to what you see on the right. So of the respondents, only 2 were large when we did the survey, but many of them thought they would be growing significantly and become large in 3 years. So fewer small companies, more large companies. So in other words, the companies that answered our survey said they're growing, they're looking to hire. So we wanted to know, what kind of people are you interested in hiring? And here are some of the results of that part of the survey. So on the left are some of the data showing how many individuals they have now and how many they thought they would have in 3 years. Of course, this was pre-COVID, who have a PhD, that's green, a master's, that's blue, a bachelor's, that's red, or earlier, high school or associate degrees, which are less significant today. And all of these high-level degrees, bachelor's, master's, and PhDs, are going up over the next 3 years, according to the companies that responded to the survey. And when we asked them what the degree types they were looking for, they were a mix, all kinds. And of course, there are different kinds of companies. Some of them really need more engineers, and some of them need more computer scientists. But the important message here is that there's a diverse need out there. And no matter where you're coming from and what background you have, you likely, if you're interested, can get involved here and make a difference. So the opportunities are growing at all levels and in all fields, or many fields. We then asked a question about what the knowledge or skills that's missing from their new hires look like. And this is sort of a word cloud that is somewhat misleading. Low temperature stands out just because of the way we asked the question and collected the information. So don't worry too much about the size of the words here, but the diversity of them. And of course, quantum appears in many forms and shapes, but you also get embedded systems development and compilers and other areas in addition to quantum and some of the expected, I guess, skills. So again, the message is that there's a real diversity of needs here. And when we ask them, how do you think that it would be best to equip the graduates or students with the skills that you're looking for, they gave these answers primarily. Number one, add specialized tracks to existing undergraduate or graduate programs. So rather than creating a new degree called a quantum scientist or a quantum engineer with a whole new curriculum, give your engineers and physicists and computer science students some basic information about quantum, and then when they go to work, they'll have that foundation, but they'll bring their deep expertise in a particular field, which is what the companies really are looking for. So a sort of T, I guess, sometimes you talk about these T skills where you have a broad but not deep understanding of a number of fields, and then a deeper understanding in your area of expertise. And another approach for educating that they emphasized highly was the use of internships. So for those of you who are in university environments or who are students, think about how to connect students to these type of internship opportunities. And QED-C is working to create a program that will help to match students with internship opportunities at our member companies. So back to the continuum, where does QED-C kind of fit into this? We see ourselves as being kind of in that valley of death. We're about helping to make sure that the enabling technologies are available so that as quantum science advances, it will be capable, or it will be able to take those research results and move them into practical applications, because you'll have photonics that don't require a whole optical bench in a laboratory but can fit on a chip. Or there will be cryocoolers that are so easy to use, they're sort of invisible to the developer. They don't have to worry about the sort of power and space and all the requirements for just cooling the systems. So this is a sort of illustrates where QED-C is focused, and in this big system, how it interacts with all the other parts of the ecosystem. So I just wanted to spend a little bit of time here. I've only got a few more minutes about my path and how I became a woman in quantum, if you will. Maybe some of you recognize this picture. I started out life as a geoscientist, a geochemist, and I studied Mount St. Helens eruption, which happened in 1980. From there, I took a postdoc where I pivoted into materials research, and I was studying the waste, the glassy waste that was proposed for hosting radioactive materials at Yucca Mountain, Nevada. So this picture shows Yucca Mountain, where there's a proposal to have a nuclear waste repository. From there, I got recruited to join the Navy as a research scientist, where I studied glass as well. All of these are glassy materials. But my interest changed to glassy materials that were useful to the Navy, optical fibers and things like that. And I ultimately ended up studying aerogels, which are a really unusual material that's mostly made up of air. From there, so I was doing what I call nature-inspired research and then use-inspired research. And then I had the opportunity to transition more into non-technical work. I was managing intellectual property and licensing out technology from the research of the laboratory. I then got the opportunity to go into policy and went to the White House and launched the National Nanotech Initiative. So this is really, these doors kind of open, and I just want to illustrate how it can work. I had no idea when I started my career that I would end up working in the White House and creating a new national initiative, very similar to the one that's being set up now in quantum. I then left the White House and went to the private sector and worked in an industry consortium that was in the semiconductor space and was about continuing Moore's law. And so there I was helping bring together the ecosystem, the university and industry and government contributors to advance a technology very similar to what I'm doing now. And finally, I got to create a quantum ecosystem. So it's been an exciting path. And I'll just end by pointing out that quantum is not all that new, even though we think of it as sort of a shiny new thing. These are some of the founding fathers of quantum. And guess what? Well, they're all men and they're all physicists. But they were great thinkers, and they laid the groundwork for what we're really experiencing today, over 100 years ago. You can even buy, I found out, a t-shirt or a sweatshirt with the founding fathers, some of them shown on it. So I would say what the ecosystem needs is not just physicists and not just men, but scientists and engineers from many disciplines. physics, but also computer science and other fields, and from all parts of the ecosystem. So wherever you are, there are opportunities. We need educators, of course, from early years through professional development for mid-career people who are interested in getting upskilled. And we need all these enabling technologies, so not just quantum. We need computer scientists. These systems, the quantum computers and everything, are not going to do much good if we don't have software. And then we need non-scientists and engineers, if you will, or people who are working in other collaborative or supportive areas like investors, VCs who actually get the technology. And then there are things like lawyers, patent lawyers and other types of lawyers, or marketing and sales people, business people, all going to be essential to advancing it. So it really is going to need you. So I'll just end with what I call the Quantum Sisters. And I look forward to the rest of the meeting. I apologize again for getting a late start, but I'll just kind of wrap up by saying the path you take will no doubt lead to unexpected places. Mine did. And so if there are questions, I can see the chat, but I can't hear anything. So I will leave it there. Thank you very much.